Hello everyone, this is Deep. This video is part of my physics reassessment quiz. So in this video today I'm going to solve a question concerning momentum vector and the force of gravitation. So in this question I have been given a coordinate system whose origin is at the center of the sun and in which the earth orbits around the sun. I have been given the mass of the sun, the mass of the earth at a particular instant, the earth's position, and the velocity by which it revolves around the sun in its orbit. So I have been asked to calculate the force of gravitation on earth by the sun and the change in momentum of the earth after 5 days. So first, to solve this question, I have drawn a free body diagram over here which represents the xy plane, as you can see. And so as I've said earlier, I've been given the mass of the earth, the mass of the sun, sun's position, earth's position, and change in time, which is given by del t. So let's first convert the 5 days to seconds. Now, as you can see, to convert the 5 days to seconds, I have multiplied by 24 times 60 times 60, which gives me the value of 432,000 seconds. Now, I need the distance between the earth and the sun, which is represented by r vector here. So this can be found out by taking the difference of the position vector of earth and the sun. So this gives me the value of 1.5 into 10 to the power 10, 0, meter. Now we know that the force of gravitation between any two objects in this universe is given by this formula here, minus g times m1 times m2 over the magnitude of their distances and times the unit vector in that direction. So here g represents the universal gravitation constant, which has a value of 6.7 into 10 to the power minus 11. And now we have to calculate the magnitude of the r vector. So to calculate this magnitude, I have taken this square root of the squares of the direction in x, y, and z direction. So this gives me the value of 1.5 into 10 to the power 10. And to calculate the unit vector, we know that we have to divide that vector by its magnitude. So this gives me the value of 1, 0, Now by the definition of the unit vector, I know that its magnitude must be equals to 1. So here when we take this magnitude, we will have the magnitude of 1, so we don't have to worry about here. And now finally I can put their magnitude and multiply and divide them out. So this gives me the value of minus 3.6 into 10 to the power 24, 0, Newton. Now we are completed with our first part. Now in the second part, to calculate the change in momentum for the earth, we have to first find the initial momentum, and as we know that the initial momentum can be found out by multiplying its mass and velocity, and this gives me the value of 0, 1.2 into 10 to the power 49, 0 kg per second. And we know that the net force acting on the earth is the same gravitational force between the earth and the sun. That force is the force by which the sun pulls the earth towards it. So now our final momentum can be calculated by this equation here, and when we evaluate this equation, we get final momentum equals the product of net force time change in time plus initial momentum. So when I put all these values together, I get the final momentum of the earth to be minus 1.56 into 10 to the power 30 times 1.2 into 10 to the power 49, 0 kg per second. So the final momentum of the earth around the sun in 5 days is calculated here. I hope you like this video. Thank you.